Okay, so in this video, I'm going to show you a little bit about normal distributions. So remember, a normal distribution is indicated by a continuous random variable. So here we have a variable x and it's distributed normally. That's what this indication is, with a mean and a variance. And so in this notation, the first number is always the mean and the second number is always the variance. So there's three examples I wanted to take a look at. So we're going to deal with a different distribution though. So it's going to be y as our our continuous random variable. So y is distributed normally. It has a mean of 50 and a variance of 25. And we want to find the probability that y is going to be less than 55. So this is actually a question we can do without a calculator. And the reason why it's a question we can do without a calculator is because 55 is actually a perfect standard deviation above the mean. So what I mean by that is, remember that this 25 is our variance. So to find the standard deviation, I take the square root. So that would be 5. So 55 is the mean plus the standard deviation. So that means y is contained with one standard deviation to the right. Here's my normal curve. Here's my mean. So 55 would be exactly one standard deviation to the right and all of the data underneath. I often will draw diagrams like this, even if I'm going to use my calculator anyways, just to ensure that I have about the correct answer. Because I should expect that my answer is going to be greater than 0.5, because more than half the curve is filled up. In fact, I believe my answer is going to be around 84.1, but let's take a look to see if we're correct. So I've reset my calculator, and I'll just go to regular calculation, and I'm going to go second function, vars for distribution. Hope this still records. And I'm going to choose Normalcdf. So choosing Normalcdf, I get my Normalcdf wizard. Now, it's saying my lower is -1e to the 99. So that means it's way over here. And in fact, in our lower, we only have to enter a number that's about 4 or 5 standard deviations below. So I'd be welcome to enter just 0 if I like it. I would still get the appropriate probability. But because this really large negative number is already there, I'm going to leave it there. Now I'll enter my upper. So my lower bound is way off in this direction. My upper bound is right here. And that's at my observed value, 55. So my upper is going to be 55. Now my mean is 50. And here's the tricky part. Remember, our variance is 25, but here it's asking for a standard deviation. So I'm going to put 5. Of course, if you didn't know the perfect, nice square root of the number, you could just type in second function to bring up your radical sign and do the radical of 25, and it would accept that and give you the correct answer. Now we'll go ahead and hit paste. It'll copy that information in, and it'll give us our answer. And just like I had said, it's 84.1%. And I know that because I've gone ahead and memorized my normal curve and the area underneath some common, standard deviations. Okay, so for the next one, here I need to find the area from 25 to 55. Let's draw a picture and see what that looks like. So whenever I draw a normal distribution, I just draw a curve and I usually put a line indicating that that's where the mean is. Now 55 is going to be this observation right here. And this is 50, this is 55, 25 is going to be way out here. So I'm looking to find the area underneath the curve from 55 to 25. Basically, I'll go back into my distribution. I'm choosing Normalcdf. I'll set my lower to 25, and I'll keep everything else the same because the upper is still 55. Now, remember 25 and 50, they're 5 standard deviations apart. Now, the amount of data contained after the 5th standard deviation is so significantly close to 0 that I'm pretty sure to 3 significant figures, this answer is going to be the same, which is why I haven't deleted it off of the previous one. Let's see how close it actually is. So 5 standard deviations away, and we're 7 digits in before we have any difference? Neat. I suppose it really didn't matter that I used a lower bound like -1. I could have used a lower bound like 0, and I would have been definitely within 3 significant figures. Cool. So this is going to have essentially the exact same probability to 3 significant figures as well. All right, now let's do one that's not going to have the same probability. So we'll take a look at y is greater than 47. Now, I like drawing my mean in sometimes. So there's my mean, it's at 50. 47 is just below it, and I want y is greater than 47. So that's everything off to the right. So if I want to do that, I'll go into second function vars to pull up my normal distribution, and I'm going to use the CDF, not the PDF. Now my lower is the bottom of my interval. So in this case, it's 47. My upper is the top of the interval, and it goes on and on and on and on forever. But as we saw, really I only need like 3 or 4 or 5 standard deviations above. So if I picked a number like 75, that's going to be more than enough. So just to be 100% sure, I'll pick a number like 1,000. That's going to get it to match really closely. Now, because I've used the exact same distribution the whole way along, I don't have to adjust these 2 numbers. I'll go ahead and paste it in and I'll get my answer. So it says 72.5 or 72.6% of the data is contained within there to there. Now, 47 is just, it's a little bit less than 1 standard deviation below. So that's going to be a little bit less than 84%. So yeah, that answer makes reasonable sense to me. And so we end up with approximately 72.6%. And that is how you use your TI84 to calculate normal distribution probabilities.